Hey, I'm Andy and I'm here with ORYX today, and we're going to talk about the components of a rifle scope for long range shooting. So, a scope that's going to work for long range shooting doesn't necessarily have to be expensive, but there are some components that we need in order to make it work properly. So, some things to look for are an objective lens that has enough size to gather light. So in this case, we've got a 50mm objective. And then we have an adjustable elevation turret, windage turret, parallax knob, zoom, and diopter adjustment. So each one of these things has a different function, and we'll go through those right now. So starting at the eyeglass side of the scope, we've got the diopter. So what this is going to do is set the reticle focus and like your base focus for the scope. So what you'll want to do is bring that over to about 6 to 7 power, adjust your parallax knob to infinity, and then adjust the diopter until you get a nice clear reticle, something where you can read the lines and the numbers very easily. Your elevation and windage are going to control where that round impacts based on where you aim. So as we turn the turret counterclockwise, it's going to raise the point of impact up, and clockwise brings the point of impact down. And then the windage turret, as we turn the turret clockwise, on this model and most models, it's going to turn the strike left. So it's going to bring the point of impact left. And then as we bring the turret back counterclockwise, it's going to bring the point of impact right. Okay, and so some other features that are helpful are a zero stop, and what that does is when you go back down to zero, it'll stop at or near your zero, and that'll keep you from losing where you're at in the travel. So when we say adjust for a 1,000-yard shot, we adjust out to that elevation, and then it allows us to go right back down to zero without losing where we're at in the travel. All right, so what we have here is a Vortex Viper that is a second focal plane. Now, what second focal plane is just simply where the reticle is placed in the erector assembly. So on a first focal plane, it's placed at the front of the erector assembly, and all that means to you as a shooter is that when you zoom in and you zoom out, you're zooming in and out on the reticle with a first focal plane. So the way you can tell for sure is if you zoom in and the reticle gets bigger, you know you have a first focal plane. If you zoom in and the reticle stays the same size, you know you have a second focal plane. Now, which one is right for you? First focal plane, the benefit is that your reticle will always be true. So if you're at 1 mil in your reticle, it's actually going to mean 1 mil on the target. With a second focal plane, you have to be at one particular zoom level for it to actually be accurate. So for most of our purposes, a first focal plane scope is going to be what you need, and it's going to work better for you. All right, and the next question that comes up are the adjustments, mils versus MOA. There are two different adjustment styles that manufacturers use. One is mil radian, one is MOA, minutes of angle. And if you're trying to decide which one you have, mils are graduated in a base 10 system. So if you see like on this scope, it'll say 0, 0.1, 0.2, 0.3, 0.4, 0.5, all the way out to 1 mil. On an MOA system, it's graduated in quarters. So you'll see 0 and then 4 lines and then 1. So what that is just two different ways of doing the same thing. The most important thing that you need to decide if you're buying a scope is, do you want mils versus MOA? It's my opinion that you should probably go with mil radian. And that's just due to that it's becoming the industry standard. More people on the range are going to be using mils, and more people at matches are going to be using mils. So if you're out with other people, it's going to give you the same language. They both work, but I would use mils